we are going to take a look at the Puppet server in production and managing certificates, introduction to community modules and Puppet Forge, managing module dependencies and librarian Puppet, managing environments with R10K, understanding roles and profiles, writing and managing a module, and finally, understanding and using Hiera. In the previous video, we went through an overview of the Puppet language and learned to write a basic module. In this video, we will learn about configuring parameters on the Puppet server for optimal performance in production, managing certificates on the Puppet server using alternate DNS names for the Puppet server certificate, and using the autosign feature to automatically sign client certificate requests. The default Puppet server configurations work for most infrastructures. However, a very important consideration when configuring the Puppet server is the memory requirement. The maximum heap size configured with the XMX option is the maximum memory that the Java virtual machine can request from the operating system. It is advised that the minimum heap space that is configured with the XMS option should be equal to the maximum heap space. The default value of 2 GB of memory is good for small infrastructures. However, with the increase in the size of infrastructure, this value needs to be increased accordingly. Another option, the heap dump on out-of-memory error, can be configured, which causes the JVM to dump a memory snapshot of the time when an out-of-memory error occurs in the form of a .hprof file. This file can then be analyzed in different profiling tools to find out more about the memory consumption at the time of the error. Managing certificates on the Puppet server. There are few actions that can be performed on Puppet certificates in the Puppet server. The primary actions are to list the certificates, to sign certificates, and to remove or delete certificates. To list the certificates, we need to execute the Puppet cert list command. This command gives us a list of certificate signing requests which have not been signed yet. To view all certificates, we need to add --all at the end of the command. To sign a certificate, we need to execute the Puppet cert sign command along with the agent name. If we have multiple requests, we can sign all of them at once by using the --all option instead of the agent name. Often we have nodes in the infrastructure which have been deleted or terminated, and the agent certificates are no longer valid, or we need to create a new agent with the same name as an old node which has been terminated. In these cases, the certificate needs to be removed from Puppet. To do this, we need to execute the Puppet cert clean command along with the agent name. The next thing we are going to look at is the process of using alternate DNS names for the Puppet server certificate. Just like Puppet agents, the Puppet server also has a certificate which defines the identity of the Puppet server. It contains information about the name of the certificate and the additional DNS names with which the certificate can be called by the agents. When the Puppet server is started for the first time, a certificate is automatically generated with the fully qualified domain name of the host on which the Puppet server is running. To view the certificate, we run the Puppet list --all command, and we are able to see the default key that has been generated for the Puppet master. Here, the host is called Puppet master, so we see the key has been automatically named puppetmaster.local, and the alternate DNS name is Puppet. So the agents will be able to communicate with this server with both the names, that is puppetmaster.local and Puppet. We have now decided that we want to access the Puppet server with additional names. If we now try to access the Puppet server with a different name, the process will fail. To make this possible, we will need to remove the existing certificate and generate a new one with additional options. To remove the certificate, we will run the Puppet cert clean command along with the certificate name of the Puppet server, which is puppetmaster.local. And there we have seen that it has removed the certificate for the Puppet server. The next thing we are going to do is we are going to run the Puppet cert generate command with the name of the Puppet server. So this is going to be the name of the certificate, and these are going to be the alternate DNS names with which we can call the Puppet master. So we have added the names Puppet, Puppet master, Puppet server, Puppet master.local. The agents will be able to communicate with the Puppet master with any of these names. Once we execute this command, the certificate should be generated and automatically signed by the Puppet server. What we can do is now we can list the certificates. And now we can see we have a new certificate called Puppet server.local, and the alternate DNS names are Puppet, Puppet Master, Puppet Master.local, Puppet server, and Puppet server.local. If the certificate is not signed automatically, we will need to sign it manually by running the Puppet cert sign Puppet server.local command along with the allowed DNS alt names option. Once the certificate is generated, we need to perform one last step. We need to add a couple of parameters to the puppet.conf file of the Puppet server. For this, we will need to open the puppet.conf file, and we need to add two parameters here. The first one should go to the main section. It is called cert name, and we will add the name of the certificate that we just generated. The next option should be in the master section, which is DNS_alt_names, and it should be a list of the DNS names that we have added as alternate DNS names for this particular certificate. We can now save this file, and the last thing we will need to do is do a restart of the Puppet server. Finally, we will look at how to use the autosign feature to sign certificate requests automatically. As the infrastructure grows, there will be hundreds and thousands of nodes connecting to the Puppet server and making certificate signing requests. Wouldn't it be better if there was a mechanism to make this happen automatically? There is a solution to this problem, the autosign feature. To implement this, all we need to do is create a file called autosign.conf in the Puppet config directory, that is etc puppet labs puppet, and create whitelist entries in them in the form of DNS names with wildcards, or accept any hostname with a wildcard entry or an asterisk. By default, Puppet searches the autosign.conf file in the default config directory, that is etc puppet labs puppet. If you choose to create this file in a different location, it can be defined in the puppet.conf file under the master section with the autosign parameter and then specifying the path of the autosign file. To see this feature in action, we will go to the etc puppet labs puppet directory and create a file called autosign.conf. And for now, we will accept all nodes which are from the .local domain. We will now save this file, and then we will run the Puppet agent from one of our nodes. Previously, when we ran the Puppet agent command on our agent nodes, we had to go back to the Puppet master and sign the certificate requests manually. Since we have now added our autosign.conf file, we wouldn't need to do this. All we need to do is run the Puppet agent command with the server name, Puppet server.local, that is the name of our certificate. There we see a new request being created, and it has been automatically signed by the Puppet master without any manual efforts. There's one more thing we are going to try out here, is to run the same command with a different Puppet server name. As we have already configured alternate DNS names for our Puppet server, all the other names should work. We have already tried this with Puppet server.local. The next thing we are going to try with Puppet server. Yes, and we see that it works. We are going to try it with Puppet master, and it works too. Tools, overview of Puppet Forge, and the procedure of publishing modules to Puppet Forge. It is great to be able to write modules for our infrastructure. However, we can't ignore the fact that it requires a good investment of time and resources depending on the size and complexity of the infrastructure. The massive community of Puppet users have come together in an effort to create community modules. Community modules are generic modules which are written and maintained by Puppet users from all around the world and can be used by all other Puppet users by modifying a small amount of data. They are hosted on Puppet Forge or GitHub repositories. Selected modules in Puppet Forge are supported and approved by the Puppet organization. They can be reused without getting into the complexities of module configuration logic. There are a lot of custom resource types to help people configure their infrastructure with minimal knowledge. The reusability enables fast delivery of infrastructure code and deployment of infrastructure. The next topic that we are going to look at is Puppet Forge. Puppet Forge is a repository of modules where Puppet users from all around the world can upload and publish the Puppet modules to be used by the rest of the Puppet community. Some modules of the Puppet Forge are supported by the Puppet organization and some are approved. Puppet Forge has a version or release-based structure where users can download a specific version of the module without the danger of breaking infrastructure with new or changed code. At present, there are over 4,800 modules hosted in Puppet Forge. The website for Puppet Forge is available at forge.puppet.com. The workflow of Puppet Forge is fairly simple. An user or employees of an organization or a Puppet Labs employee can upload and publish Puppet code from any location via the website forge.puppet.com. This code can then be fetched by any user or organization employees via the Forge API.puppetlabs.com API endpoint. There are tools to help users achieve this, which will be discussed in the next video. Next, we will look at the procedure to publish a module in Puppet Forge. The workflow of publishing a module in Puppet Forge consists of the following steps. The first task is to create a module. The next step is to update the metadata.json file in the module directory with some required information and then build the module or create a tar.gz package of the module. We then need to create an account on Puppet Forge and upload the package and then publish it. While creating a module, we need to keep in mind that it requires a specific naming convention. To publish a module in Puppet Forge, we need to create an account and the account has a username. The naming convention of the module should be the Puppet Forge username followed by a hyphen and then the actual module name. When the module is generated with this naming convention, the module directory will be created with just the module name, but the module name in the metadata.json file of the module will actually have the name which is required to upload the module to Puppet Forge. We will look at a hands-on example for the same. The first thing we are going to do here is create a module with the Puppet module generate command, and we will add the skip interview option, and then we will add the Puppet Forge username, which is extending Puppet with a hyphen, and then the name of the module, which is example module. What the skip interview option does here is that it skips a series of questions that are asked by Puppet to determine the contents of the metadata.json file. Once we run this command, a directory is created called example module. Do note here that we mentioned extending Puppet-example module. However, the directory that got created has just the module name, that is example module. The next thing we are going to do is update the metadata.json file. We will open the metadata.json file in an editor, and here we see that although the module directory was named example module, the name of the module in the metadata.json file is still extending Puppet-example module. This is required to upload the module to Puppet Forge. The version of the module has automatically been generated by Puppet. We need to keep increasing this once we add changes to our modules. The next thing we will do is add a summary to our module, which is mandatory. We'll just say an example module, and we will add a source, which is the URL of our GitHub repository. We will then save this file. The next thing we are going to do is create a tarball for our module. To do this, we need to go to the module directory and run the command puppet module build. Once we do this, we can see a new directory has got created in our module, which is the pkg directory. Once we check this directory, we can see we now have a tarball for our module. This file now needs to be uploaded to Puppet Forge. The next thing that we're going to do is upload our tarball into Puppet Forge. First, we need to sign up, which is a pretty straightforward process. And then we need to log in. Once we log in, we should have an option here called Publish Module. And then we need to choose the file that we want to upload. And there we have our module. It says your release uploaded successfully. So here we see we have a release version. So as we keep making changes to our module, we'll increase our version and we'll keep uploading tarballs, and it will be listed here as different release versions. That's all we need to do to upload and publish modules.